good? All right. Okay, so quick reminder. What are logarithms? They are exponents, right? So remember how the last lesson we said, you know, if you have log base 2 of 8, what is that logarithm equal to? It's saying 2 to what power gives us 8? 2 to the third power, right? Right. If I said log base 5 of 25, 5 to what power gives us 25? 2. Right? Now, when we did that, we made it equal to x and we changed it around, right? But really what we're saying, these logarithms, they are exponents. They are equal to an exponent. Okay, so because they are exponents, they are derived from the properties of exponents. Okay, so product, quotient, and power. So for example, right, let's start with the product property. If you have x to the third times x to the fourth, what do we do with the exponents?
Add them.
We add them, right? Correct. So we add the exponents. So notice when we have a log base b of m times n, we can expand this to adding each exponent. So these two multiplied together becomes log base b of m plus log base b of n. Okay. So let's take a look at why does that work. Okay, so log base 2 of 8 times 4 is the same as log base 2 plus log base 2 of 8 plus log base 2 of 4. So let's look at the right side. What's log base 2 of 8? 3. We just, right? 2 to what power gives us 8? We said 3. 2 to what power gives us 4? 2. So that's going to be equal to 5. Now let's look at the left side. Let's say we multiplied together the 8 and the 4. That would be 32. Okay, so using that same idea, 2 to what power gives us 32? 5. Okay, so anytime we have two numbers multiplied together with one logarithm, we can expand that to adding each individual part. Make sense?
So you recommend
What's that?
do you recommend going right to the left?
Yeah. So, okay, so here's an example. So I have log base 3 of 14. I want to evaluate. And let's say I know log base 2, or sorry, log base 3 of 2 is 0.63010, and log base 3 of 7 is 1.7712. So, yeah, so how can I rewrite log base 3 of 14? I can write that as log base 3 of 2 times 7. Because if I know 2 and 7, how can I expand that? I'm going to rewrite this as log base 3 of 2 plus log base 3 of 7. What? Okay, so I'm taking 14 and I want to rewrite it as a product, and then using the product property, we're going to add those two together. Why do I want to do that? Well, I know what log base 3 of 2 is. That's what? 0.631. And log base 3 of 7 is 1.7712. Can I add those two together?
Yeah, 2.400022.
2.4022. Okay. Good.
All we have to do is just add them together.
Yeah, so we're basically taking the product and we're rewriting it as a sum. 'Cause-
How many have you been?
What part don't we understand?
Like the first one.
Rewriting 14 is 2 times 7? Because I know, because I'm told, I know what 2 is equal to, and I know what 7. I know what the log of 2 is and the log of 7.
I thought you said that one was.
No,
that I'm saying it.
This here? From the property.
Oh, okay.
When you have two things multiplied together, each one of these is an exponent, so we can
break it up.
yeah, so we can break it up.
I want you to figure this out.
It's kind of like, let's say we're working backwards. Let's say it was x to the 9th power. I can break this up into x to the 4th times x to the 5th, right? So it's kind of like we're working backwards, but with logarithms. So I'm saying, how can I like break this up into smaller parts so that I can substitute those values in? Let's start with a different example. Let's say the quotient. So let's say I have x to the 10th power over x to the 6th power. What do I do when I have a quotient? I subtract the exponents. Right? So same thing for logarithms.
That's pretty easy.
So if I have a logarithm where you have two things divided, we're going to expand that by subtracting each individual part. Okay, so this one's just like the last one. Log base 2 of 7/3. How can I rewrite that? Log base 2 of 7 minus log base 2 of 3. What's log base 2 of 7 equal to? 2.807. And the other one?
1.535.
Okay.
1.222.
1.222. Okay. One more property is powers. So what if I had x to the 3rd raised to the 4th power? What do I do with the exponents in this case? We multiply them. Okay, so if you have log base b of m to the p, that power gets multiplied to the front. Okay, so we multiply the number to the front. Okay, so now we're going to do a combination of things.
Do we keep the power on the bottom too? Like for
Yeah,
the A, like we do like 2 times.
everything stays the same, but the exponent goes to the front.
But you also keep it over there, right?
Yeah.
Why do you multiply?
Because you multiply the exponents. So remember, it's like this is the extra exponent. It gets multiplied to the front.
I'm just confused to figure out where everything goes. Yeah,
It goes 2 times log 2 times.
Okay.
Right?
2 times.
2 times log.
Well, hold on. First thing I want to do, I want to rewrite 36.
And 7.
We could do 6 squared, but all I know for this one is log base 2 of 3 and log base 2 of 7. So how else can I rewrite 36?
6 squared.
Yeah, but I don't know what log of 6 is.
7.
Here, let's take 30.
7 and 5.
So you said 6 and 6.
Even if I don't multiply the 36.
Yeah.
So I can rewrite 36 as 2 to the 2nd power and times 3 to the 2nd power. Right? 4 times 9. There's a reason. You'll see why. Okay. Now what? Okay, can I rewrite what's inside here using the product and the sum? Okay, let's start with the multiplication part. Remember multiplication, I can rewrite this as log base 2 of 2 squared plus log base 2 of 3 squared. Okay, now what? Okay. Okay, so the exponents, I can move them to the front. So I'll have 2 times log base 2 of 2 plus 2 times log base 2 of 3. Okay, so the first step was taking the multiplication and turning that into addition. And then the second step is moving the powers to the front. So that's using that property above. Why am I using 2 squared? You'll see. Just look at log base 2 of 2. 2 to what power gives us 2? 1. So I'll have 2 times 1 plus 2 times, in the directions, do I know what log base 2 of 3 is? 1.585. So here's the goal is to get rid of all the logarithms, right? And by either evaluating, because we know, could you also have done, what's 2 squared? 4. 2 to what power gives us 4?
2.
So I can do it either way. I can figure it out here, or I can move it to the front.
So when you do 2, what cancels it out? The 1?
Whenever these two are the same, it's equal to 1. So if this was a 3 and this was a 3, okay. If it was a 9 and a 9, it's always going to be 1.
Okay, let me know if there's anything.
Okay. All right. What do we get when we put that in? Anybody?
4.
4? No, not 4.
It's not 4.
Can't be 4.
It is
What is it?
5.16.
5.16?
5.17.
5.17?
What? No, man, it's not 5.16.
It's 5.17.
I got 3 points. I got 3.16.
Okay.
Okay, yeah, it is. I did something wrong.
All right. Log base 2 of 0.75. This 0.75 is a fraction. 3/4. Okay. You're what? To wake up. A little late.
This is spring break alarm.
That's spring break. It's still early for spring break alarm.
A little.
Okay, how can I rewrite 3/4? What do I do when it's a divided by? We're gonna make it a subtraction. Okay.
Log 204.
Just a quick reminder, here we go. N divided by n, we're gonna make log of m minus log of n. So log base 2 of 3 minus log base 2 of 4. In the directions, do we have log base 2 of 3?
Yes.
Yeah.
Yes.
1.585.
And log base 2 of 4 is 2.
2.
1.5 and 2 equals. What's the answer? Oh.
Yeah, because if we have a power of 2, we can just simplify that. Okay. How did I get what? Yeah, you don't have one. I didn't give you in the directions. I didn't give you a log of 6. Look in the directions. I didn't even use the log base 2 of 7 at all. I just used this one. If I gave you log base 2 of 6, then I could use 6 squared. Okay? All right. All right, now we're going to solve. Okay, so working, we have log base 5 of m and 1/3 log base 5 of 125. What happens when, so now we're going to work backwards. If there's something multiplied to the front, we're going to move it to, we're going to move it to the exponent. Now we did this yesterday. When you have the log of the same base on both sides, what happens to them? They cancel each other out. So we're left with m equals 125 to the third power. And then what's the 1/3 power mean?
Means like cube root.
Cube root. So
Oh, so it's just m equals 5.
what's the cube root of 125? 5.
Oh, okay.
Okay.
But don't you have to do it to the?
It's 1/3 power, so we rewrite that as a cube
We
root.
don't have to do it to the n.
No.
Oh.
What's that?
Oh boy.
She's coming now, but she's
Oh,
she's
okay.
taking a look at her paper.
Got it. Okay, let's take care of the next one. What we want to try to do is we're going to condense everything into the log base 3 on both sides. So first thing, I'm going to move the exponent to the back. Okay. Now you can combine steps. I just wanted to, we always take care of the powers first. Okay, take care of the exponents first. So if you have a coefficient in front of a logarithm, you're gonna move that to the exponent. Okay, so first, before we cancel, we can only do it if it's one logarithm and one logarithm. So you see how there's a plus sign on both sides?
Yeah.
So now we're working backwards and the plus sign will be combined to make it y squared times 0.01. Log base 3 of 5 times 2. Okay, so we can only cancel the logarithms when it's 1 on each side. Okay, you can't have like a plus sign and they don't cancel like that. Okay, does that make sense? So you want to group everything together. Now that you have 1 log base 3 on each side, now they cancel. So that'll be 0.1 y squared. And on the right side, that'll be equal to 10. Does that make sense? So you always have to combine everything. So you just have one log, they cancel. Then what do we want to do? So now we're solving for y.
Divide by 0.1.
Okay, so divide by 0.1.
Is y squared equals 100
Y squared equals 100.
Yeah, this isn't bad at all.
Now, it would be plus or minus 10, but can we have a negative value? No.
So why only?
Yeah, so y only equals 10.
There's more.
Why would it be minus?
There's more. More. Jesus.
Because if you remember we talked about yesterday, you can't take a logarithm of a negative number.
No, but why would it be y equals plus minus?
Because anytime you take the square root,
Oh, as long
It's-
as,
you-
as long as it's a square number.
yeah.
So like if it was
If it's y,
72, it would, oh wait, no.
you'd still have plus or minus.
I know, that's why I realized it was the wrong example. So like 42, it's on square root. So it's
Right.
yeah, plus minus.
Okay. Just a few more examples. Okay, what do we take care of first?
With the code.
The exponent. So anything that has a coefficient moves to the exponent. Okay, on the left side, there's nothing we could do. So log base 7 of 64 to the 1/3 plus log base 7 of 121 to the 1/2. We could combine the right side. So that's going to be log base 7 of m equals log base 7. Now, 64 to the 1/3 is also cube root of 64. I'm going to make that times. And then what would 121 to the 1/2?
Wouldn't that be 4 square root?
Yeah, that would be 4. That's what I was saying, like sometimes you can combine steps.
Do you want us to leave it like
Can we
that?
cancel the logarithms now?
Yeah.
Yeah, because now I have one of each. So m equals, well, what's cube root of 64? 4. times,
11, so M equals 24.
good.
Oh, never mind, I got it.
Okay. All right. Left side. What can we do to combine those? It's going to be log base 6 of x times x plus 5 equals 2. Okay, this one looks a little different because we don't have a log base 6 on the right side. Okay, remember, yes, can we change this to exponential form? Remember what we did yesterday? So base 6 becomes 6 to what power? Remember, 2 equals.
X times X.
Remember, yesterday we worked on changing things. If there's only one logarithm, we want to change it to exponential form. 6 to the second power. Remember, the logarithm is equal to the exponent equals x times x plus 5. All right, what do we do from here? Now it's just an algebra problem.
X squared.
Okay, so
X squared.
36 equals x squared plus 5x. Move everything to one side. Okay. We have two numbers that multiply together to give us negative 36.
-9 and +4.
Negative 9 and positive 4 or
Oh, no,
positive 9?
9 and negative 4.
Okay, plus 9 minus 4. That works. Okay, so what do we get for x?
4 and 4 and negative.
Okay, negative 9 and 4, but what?
You can't count negative.
You can't have the negative, so it's just going to be
4.
Okay. Two more, and then looks like we will have some time to start homework. Okay, first step is to, oh, you want to try this one on your own, or is this one?
What?
It's got a subtraction. No?
Okay.
No?
There you go.
Come on, you can do this. Move the exponent first. You can move the exponent.
Would it be x to the 4?
It would be. Okay, this one has a subtraction sign. So subtractions turn into division.
So it'd be
X to the 4th over 5. Good. Okay. This one is like the other ones we did. You have a log on, so now we have one log on each side. So they cancel, and we get x to the 4th over 5 equals 125. Multiply by 5.
So then X to the 4th equals
Good.
Yes.
All right. Good. Last one. Okay, so take care of the exponents. There's just one. So log base 7 of
X squared.
x squared. How about the right side?
That's gonna be a big number.
Okay, my recommendation is to not multiply those together. Because what's gonna happen with logarithms? The logarithms are gonna go away. And when I take the square root, could I do the square root of 27 and the square root of 81?
Yeah, 9 and 3. Or no.
There's no square root.
This is 9,
Yeah, it's
and this
9.
is gonna be 3 root 3.
Yeah.
And so we get, which is a lot easier than trying to multiply those together and then break it down. Okay, so if you have two numbers like this, I wouldn't actually multiply them, I'd do the square root and simplify each part. Does that make sense why I didn't bother?
Yeah, yeah, that's all it was.